Hello dear student, this is NEELAM JOSHI and today I am going to discuss about cloud computing reference model and the subject code of cloud computing is MCA 503. So here are the outlines which we will cover in today's video, in which prerequisite of topic, then problem objective, then we will discuss about cloud computing reference model, then some supporting model of cloud. Then we will discuss about how to connect cloud and architectural view of cloud in the form of diagrams. Then we will discuss about various types of layers, description of cloud. Then the exercise which is based on today's video, then learning outcome, and finally references. So first of all, prerequisites of topic. Before discussing about reference model for cloud, you should have knowledge about what is actually the means of cloud computing, and also various types of cloud, that how the deployment of cloud is performed, as well as you have to knowledge about various types of characteristics, in my previous video we already discussed about lot of characteristics, benefits, and limitations of cloud. So you should have knowledge about these type of characteristics. Like if we talk about on demand self service, then what is the actual means of on demand? So basically here I just want to recall you that here whenever we talk about on demand service, then a consumer here is basically used and it can provision the computing capability in the form of time and network storage as needed automatically without requiring human interaction. And it also provide broad network access, which shows the capability which are available over the network and access to different standard mechanism. And for this purpose, whenever we are using these type of broad network, then we will refer mobile phones, laptops, and PDS for the same purpose. And also we discuss about resource pooling, actually, where the providers computing resources are pooled to serve multiple consumers using a multi-tenant model. And here this multi-tenant model is just use the physical and virtual resources dynamically assigned and reassigned according to the consumer demand. And then also we discussed lot about what is the actual means of rapid elasticity and scalability, and why we need scalability in cloud computing environment. So you should have knowledge about the means of elasticity and scalability. And also you should have knowledge about various type of services, which generally known as the major services, in which cloud system automatically control and optimize resources, which use by leveraging a metering capability at some level of abstraction which is appropriate the type of service. So basically the whole sense of using and discussing about these content is just to show you that how resource uses can be monitored, controlled, and reported for provisioning transparency for both the provider and consumer of the utilized service. So before understanding about reference model, you should have knowledge about these type of features and these type of benefits, characteristics, as well as the limitation. Now moving ahead, problem objective. So here the problem objective is just divided in the portion where we will discuss about cloud reference model on the basis of architecture, which is generally divided into some specific layer. And we will also discuss about how various layers participate in creation of cloud architecture, and also various types of model architecture. Now, what is cloud reference model? So here, the cloud computing reference model represents a generic high-level architecture and is intended to facilitate the understanding of the requirements, uses, characteristics and standards of cloud computing. Basically, the key to cloud computing is the cloud. Okay, and here a massive network of server or even individual PCs interconnection are available. So these computers run in parallel and combining the resources of each to generate supercomputing like power. So here the question arises is that what is actually the means of cloud? So basically, the cloud is just a collection of computer and servers that are publicly accessible by the internet. And this hardware is typically owned and operated by a third party on a consolidated basis in one or more data centers location. So basically the machines can run any combinations of operating system, and it is the processing power of the machine that matters, not what their desktop looks like. So here, according to this scenario, we will just describe the reference model, and here this reference model is generally depicted a simple and collection of some intelligent management system which is used to connect all those computers together and assigns task processing to multitudes of user. Okay, so we can say that cloud computing reference model is just used to facilitate the process of cloud modeling, deployment, planning and architectural view. And the cloud computing reference model will hopefully establish a standardized process for modeling clouds. And the cloud computing reference model here we developed by using some supporting system. So before going depth in cloud computing reference model, we just discuss about some supporting model which is on which the cloud computing model is based. So here the first one is cloud enablement model. Here the core of the cloud computing reference model is cloud enablement model, and this enablement model describes the fundamental technologies tiers of cloud computing capabilities which provided by the cloud platform and cloud service providers to potential consumers of cloud enabling technologies and business capabilities. Okay, and the next one is cloud deployment model. Here it describes the range of cloud deployment scenarios which are available to our enterprise, as well as some internal private cloud and external private cloud, as well as hybrid and integrated cloud and community or vertical cloud. So basically the deployment is based on these types of cloud methods, and these deployment scenarios may be mixed and matched. Okay, next one is cloud governance and operational model. Here this particular model is basically describe the governance, security operation, support system, management and monitoring requirement for cloud computing to ensure that we have considered all the potential operational risk of adopting cloud for our enterprise. Okay, next one is cloud ecosystem model. Here in this type of model, basically it support the cloud computing system as it consider the requirements of developing and sustaining a cloud ecosystem which comprised of cloud providers, cloud consumers, cloud intermediaries, as well as cloud network and cloud dial tone, which is necessary to ensure the cloud is always there for you. Okay, and here the cloud ecosystem always includes the various cloud enablement technologies and cloud providers and consumers of those clouds enablement technologies that comprise the cloud ecosystem. So basically these all supporting model is just used as a support system for cloud computing reference model, and here these model provide some specific features in creating of reference model, like whenever we talk about enablement model, then here it work as a cloud virtualization tier, cloud operating system tier, cloud platform and business tier. And cloud deployment model is basically work on the basis of internal, or we can say that private cloud, external cloud, which is also known as public cloud, hybrid cloud, and community cloud. Next one is cloud governance model is basically concerned with governance, culture and behavior, as well as it also relates security and privacy and management and monitoring with operations and support to the cloud reference model. And cloud ecosystem model is generally based on cloud network in the form of dial tone and cloud ecosystem enablement, cloud consumers and cloud providers, as well as cloud physical access, integration and distribution. So we can say that this supporting model is just create a baseline for referring and for managing cloud computing reference model. Now moving ahead with the description of cloud computing reference model. So here this architecture is generally based on some specific layers. So as you can see in this diagram that developing the cloud computing logical architecture, we require first of all a decomposition of the layers of cloud architecture, and these layers is generally divided into cloud application layer, cloud software environment layer, cloud software infrastructure layer, which is further divided into some specific services, and in my coming video we will discuss in detail about these services. And then software kernel and hardware and firmware layer. So we can say that in many respects the cloud logical architecture represent the traditional layer of an enterprise architecture model, but with the ability to virtualize all the logical layer as well as provide API access to cloud enable resources within the each of layer as cloud enable capabilities. So here cloud architecture is generally created in the form of pictures of cloud and other visual metaphors that allow to amazing collection of technologies packaged and available from a magic cloud in the sky. And in this view correctly we can say that the respective layers builds with the help of one another, and here virtualization technology is used to provide a robust and fairly mature capabilities for this model. And here successful virtualizing some related cases of computing infrastructure are needed, and then layering over that the ability to provision these resources to multiple internal or external consumers meters and their consumptions by actual uses. So on the basis of these features the whole creation of these cloud computing reference model is done. But before discussing about these layers in detail, first of all we should have understand that how the cloud is connected with user. So here this diagram is just show how user connect to the cloud. So in this diagram you can see that here individual user is connected with the cloud. Okay, and this is generally used its own personal computer or portable devices over the internet, And these individual users, the cloud is seen as a single application, device or document. That means whenever these all types of user is connected at the same time, but for cloud server it is generally represented in the form of either in the form of application or some specific device or document. And here the hardware is in the cloud, and the operating system that manage the hardware connection is generally invisible. That means user doesn't have any idea of how the hardware and operating system is provided by this cloud server. Okay, now the second diagram here is used to show the architecture behind cloud computing. So here in this diagram you can see that the user is generally connected with user interface, and then it is connected with system management, and then it is connected with provisioning services, and cloud service just used to provide web application. So here it all start with the front end interface which is seen by individual user. Okay, and this is how users select a task or service, either starting an application or opening a document, and the user's request that get passed to the system management, which finds the correct resources and then calls the system's appropriate provisioning services. So basically these all services is generally carve out the necessary resources in the cloud and launch the appropriate web application, and either creates or opens the requested documents. And after the web application is launched, the system's monitoring and metering function track the uses of the cloud so that resources are apportioned and attributed to the proper user. So here we have to identify that how these all services are just uh, tracked and reflected to the consumption of any user. And here uh, you can see that the key notion of using cloud computing is just the automation of many management tasks, and the system isn't a cloud if it requires a human management to allocate processes to resources. So basically here this cloud computing model is that type of model which is used for enabling ubiquitous, convenient and on-demand network access to shared pools of configurable computing resources. For example, here this architecture is just used to show the network, and here it incorporated with various types of servers, and here it also provides storage facilities, specific types of applications and services that can be rapidly provisioned and released with minimum management effort or service provider interaction. And whenever we talk about the cloud reference model, which we also discussed in the diagram, that it is built upon several functional components blocks which are organized into specific layers, and in order to maximize the value of cloud architecture, and each component must exist in some state, and cloud architecture is simply the logical conclusion of these specific types of feature. So for better understanding about cloud reference model layering system, we will just describe each layer in detail one by one. So the first layer is cloud software environmental layer. So here we have to understand what is actually the cloud environment means. So here cloud environment is one of the most pervasive and fundamental challenges for organizing and organization in demonstrating policy compliance, which is providing that the physical and virtual infrastructure of the cloud can be trusted, and particularly when those infrastructure components are owned and managed by external service providers. So basically, the cloud software environmental layer provides a programming language environment for developers of cloud applications. And here the software environment also offers a set of well defined application programming interfaces, which is also known as API, which is used to utilize cloud services and interact with other cloud applications. So in this way we can say that the cloud environment is basically sometime a source of reduced cost, because whenever we use the cloud environment, then cost saving is the transition from capital expenses to operational expenses. And when setting up a traditional environment, the infrastructure equipment which have to be purchased ahead of time is generally provided by the cloud environment. And we can relate this cloud software environment layer with business tier. That means we will also understand in the context of cloud business tier that what is actually the means of cloud environment in terms of business. So here it comprises the business or mission exploitation of cloud enabling business applications, software, data contents, and knowledge and associated analysis framework, and other cloud consumption model that facilitate and enable end user business values from cloud consumers, which have the ability to access, bind, and consume cloud capabilities. So for many business functionalities, we commonly run in the cloud platform, which hosting websites and sometimes Wikipedias for the enhancement of services and facilities provided by the cloud environment. And basically this environmental layer is work on the basis of programming environment. Now the second one is cloud software infrastructure layer. The cloud software infrastructure layer provides resources to other higher layers which are utilized by cloud application and cloud software platform. And you can see the same thing in this diagram, that how infrastructure layer provide the resources to cloud environmental layer, and this is just above layer of cloud infrastructure layer. Basically, the cloud software infrastructure layer is used to provide fundamental resources to the higher level, and here the cloud services offered in this layer can be categorized into computational resources, data resources, as well as communication. So we can say that here this includes storage facilities like virtualized servers and networking, and here infrastructure as a service provides and points to delivery of services in hosted format, and they include hardware, network, and server which is delivered to end users, as well as consumer can enjoy access to scalable storage and compute power as and when needed. So basically we can say that the whole infrastructure related environment is provided and handled by this particular layer. Like for example, if you want to reduce the expense of maintaining servers in on data centers, and you can rent the equipment from dedicated data centers which are placed in different places on different distances. Okay, so when you need to send some data or launch the application, then the signal will move through different points in the different cities and countries. So we can say that until it gets to the finish, you might lose time and resources. And also don't forget that the data center equipment has limited capacity. So this is one of the crucial moment when we are talking about large number of users, and the more user you have, the greater the response delay will be. So basically the means and sense of using this particular example to show you that how can we access the facility provided by the cloud infrastructure layer in a better way, so that there is a problem arises like timing, resources availability, and large number of users are generally reduced. Now the next one is cloud kernel layer. The cloud software kernel layer represents the software management environment for the physical server in the data center. Here you can see in this diagram that how physical servers are just related with this cloud which is incorporated with cloud kernel layer, and it provides management environment. So basically the sense is what? Here software kernels are usually implemented in the form of kernels, hypervisors, virtual machines monitors, or clustering middleware. And at this layer, cloud computing can benefit from the research already undertaken in the grid computing research community. So basically this kernel layer is just represented as a mediator between cloud environmental and infrastructure layer and hardware and firmware layer. Now the next one is hardware and firmware layer. So here at the bottom end of the layered model of cloud computing is the actual physical hardware which forms the backbone of any cloud computing services offering. Okay, here I have already mentioned that definition, and in this diagram you can see that this firmware layer is just provide the backbone for all the cloud services offering. And hardware can also be here subleased from the data center providers and normally large enterprises, which is typically offered in traditional outsourcing plans, but in generally used as a service context, which is also referred to as a hardware as a service. So basically here the bottom layer of the cloud stacks in our reference model is actually the physical hardware, and it switches that from the backbone to the cloud. And here users of this layer of the cloud are normally big enterprises with huge IT requirement in needs of subleasing hardware as a service. So basically we can say that this particular layer is just the backbone, in the sense where without this the existence of whole layers is just null. Okay, now here I just want to say that the whole cloud reference model is not just because the part of this layer, it is just also uses some tier in the form of physical virtualization, operating system, platform, and business tier, which I already mentioned. And here this also incorporate with the reference model in the sense of cloud consumer, cloud providers, cloud brokers, cloud auditors, etc. And in my coming video we will discuss in detail about this reference model second part in the form of these roles of cloud consumers, auditor, etc. Okay, and here I just want to mention that these all layers is just handled by the main layer, which is known as application layer. And here this application layer contains the program that transcodes each file and that create the end user interface for accepting the commands and presenting the data files, and the code interfaces with the application programming interfaces from the transformation layer with minimal concern for underlying computing platform is generally used with this application layer and with the help of some other layer. So basically in short we can say that application layer is generally used to set up the application program and architecture in the form of batch, high performance computing, and portal remote desktop. Okay, and this is the exercise which is based on my today's video, and here you have to answer the following MCQs, in which the first one is, which of the following type of virtualization is also characteristics of cloud computing? So you have to choose one option from these two, uh, either storage or application CPU. Oh, sorry, this is 3 actually. I think there is some mistake. So the third one is all of the above. And the second question is, the technology used to distribute service requests to resources is referred to as a. So just think and answer, try to answer it by own self, that what is the answer, either load performing, load balancing, or load scheduling. Next one is, which of the following is the operational domain of CSA? Here CSA is what? Cloud Service Security Alliance. Okay, and here you have to choose the option in between scalability, portability and interoperability, and flexibility. Now again, which of the following is considered an essential element in cloud computing by, again, CSA? So here CSA is Cloud Security Service Security Alliance. So you have to choose either multi-tenancy, access management, or virtualization. These are the learning outcome of today's video. So in today's video you just understand about cloud reference model, and also you have knowledge about supporting model of cloud computing and all, and we have already discussed about various types of layers. So now you have idea about how the layers are incorporated and provide the result and features for communicating with each other to create a reference model. And these are the shallow points, and here are the reference used. Thank you so much to all of you.